Good morning. Now we are going to see type 3 problem. Consider the mechanical system given below and the displacement and velocity are given for both the masses, and they are asking to obtain the state model in the standard form. Assume the velocity m2. Assume the velocity of mass 2 as output. That is, they are asking us to assume the velocity of mass 2, that is v2, as the output. How to solve this problem? First of all, we need to find the input and the output. Input here is f of t. The force is the input. Therefore, in state space representation, it is given as u of t. In the problem itself, they told velocity of m2, that is v2, is taken as the output. Therefore, we can directly take y of t is equal to v2 of t. U of t is the input, y of t is the output. Next, we must select the state variables. In electrical network, we used to take the state variable as the energy storage elements, that is inductor and capacitor. For a mechanical system, the spring and the dashpot are the energy storage elements. Therefore, we must take the displacement and velocity as the state variables in mechanical system. Therefore, see, there are two displacements and two velocities. Take x1, state variable 1, x1 as y1, x2 as y2, x3 as v1, and x4 as v2. First of all, we must write the force balance equation. For m1, for mass 1, the force balance equation we have studied in unit 1, that is input force F1 is equal to m1 into d square y1, because the displacement of m1 is y1. d square y1 divided by dt square, plus we have two elements with respect to m1, that is connected between m1 and m2. Therefore, since we are writing with respect to m1, we must take m1 as the reference. Therefore, this k, that is written as k into y1 minus y2 plus b1 d of y1 minus y2 dt. This is the equation number 1. Then, considering m2, there is no force acting on m2. Therefore, the input is equal to 0. Therefore, force is equal to m2 into d square. Displacement for m2 is y2. Therefore, m2 into d square y2 divided by dt square plus k2 into y2, because this k2 and b2 are exclusively for m2 alone. Therefore, k2 into y2 plus b2 into dy2 divided by dt. Then you must write k1 and for b1. The k1 into y2 minus y1, because in node 2 we are taking with respect to m2. Therefore, m2 displacement must come first, y2 minus y1 plus b1 d of y2 minus y1 into dt. I hope that these two expressions we have already studied in unit 1. This is the equation expression number 1. This is expression number 2. Now, change the physical variables in the expression into state variable notation. We know that the displacement y1 is taken as x1, y2 is taken as x2. Now, dy by dt. dy1 divided by dt is nothing but x1 dot. Somehow I need to find the x1 dot, x2 dot, x3 dot and the x4 dot. Here we know y1 is equal to x1, therefore dy1 divided by dt is equal to x1 dot. Similarly, we know y2 equal to x2, dy2 divided by dt is equal to x2 dot. I found out x1 dot and the x2 dot. This dy1 divided by dt is nothing but the displacement, the differentiation of the displacement is nothing but the velocity that is given by v1. Similarly, the displacement for mass 2, that is y2, if I differentiate, I will get v2. As we already assumed, v1 is nothing but x3 and v2 is nothing but x4. We have already taken these two are state variables. Now, if I differentiate x3, I will get x3 dot. Therefore, I can write x3 dot is equal to d square y1 divided by dt square. You can write dv1 divided by dt, or I can directly write, if I differentiate 2 times, I will get x3 dot. Similar way, if I want x4 dot, I need to double differentiate the displacement y2, or you can just differentiate the velocity v2. Both are same. So now I found out x1 dot, x2 dot, x3 dot and x4 dot. This is expression number 1. This is expression number 2. From expression number 1 and expression number 2, these physical variables, displacement, velocity, are replaced in the form of state space notations. Force is replaced as u of t, and d square y1 divided by dt square. In this expression, d square y by dt square replaced by x3 dot. Here we are having the s3 dot. You can compare. Similar way, k1 into x1 minus x2, because y1 minus y2, y1 is x1, y2 is x2, y1 minus y2 can be written as x1 minus x2. In the similar way, this dy1 minus dy2 divided by dt, it is replaced by x3 minus x4. We know dy1 by dt is x3, dy2 divided by dt is x4. Combining this, we are writing this expression. Similar way, equation number 2 is replaced by this expression. Take this as equation number 3 and take this as equation number 4. From equation number 3, find x3 dot, because we already found x1 dot and x2 dot. So we need to find x3 dot. From this expression, I can find x3 dot by sending all the parameters to the left hand side. Similarly, in this expression, I can find x4 dot by sending all the parameters to the left hand side. Just you need to work out in this calculation and you will get equation number 5 and equation number 6. Since x1 dot and x2 dot are has been already found, here we can directly obtain x3 dot and the x4 dot from the above expressions. We also know that in the question itself they are given output is taken as the displacement of the mass 2. Displacement of the mass 2, that is nothing but velocity v2. Here v2 is nothing but x4. From this we can find x4. As we already know, this is the state model. From the above expressions, x1 dot, x2 dot, x3 dot and x4 dot. You can rearrange these two expressions and you can write the state model easily. From the expression you can find A matrix, B matrix, C matrix, and of course here D matrix is going to be 0. There is no feed forward path. This is how you obtain the state model from the given mechanical system, from this mechanical system.